finish this up today. Hopefully we'll get a, a 5 for 10 in. If not, I got a plan for that as well. But today we'll start off with 34. Find the domain and range. Domain of the x values that are being used, and the range of the y values. I'm going to answer in interval notation. I'm not sure if that's what it says. Oh, it says find the intervals on part B. So all the x values that are being used. I'm starting at -5. Going to run to -3 and stop. So -5 gets a bracket. -5 to -3. Union. -2 to -1 looks like the next interval. Parenthesis -2, -1 bracket. Then the next interval looks like from 0 to 2. These are nice. You can do this with the x values. 0 to 2 with the parenthesis. The next round will be from 3. I don't have to stop at 4. I can actually keep going all the way to 5 because there's no break in the number line. There's no open circles. So that'd be from 3 to 5. Except 3 gets a parenthesis, not a bracket. So that's pretty nifty. Questions on that? The hardest thing is just kind of making sure you get everything as part of your answer. It's not really understanding it. It's just being thorough in your answer. The y's. I usually like start at the bottom, work my way up. Ooh, open circle at -3 and a closed circle at -3. Which one wins? Bracket or parenthesis? Yeah, bracket. Yeah, the dot fills in the open, or the closed dot fills in the open dot. That's because I'm looking for an or statement on the range, not an and statement. So I can actually use the capabilities of this technology that say, okay, I'm going to use -3, and all the values up so far are going to be used for the y values. There's not a place where it's open. That's true until y gets to 3, right? Yeah. And that's again, bracket. And then union that with the point when y equals 4. I just use sets notation right there. That's pretty nifty. But, all right, increasing. Again, we use x values to determine where it's increasing. That means that y1 is less than y2 if x1 is less than x2. I said you're going to have to use that on a proof. Let's see. Oh, here's where it's increasing. Let's use all the reds. Increasing from, I don't use it for the endpoints or at the height. So there it's increasing. And here it's increasing, going up from left to right, so to speak. So that would be -5 to -3, right? -5 to -3. Union from 3 to 4. Does that make sense? This is the second one we've done, so hopefully you get the idea. F of x decreasing. Yeah? None of them. When I do increasing and decreasing, I never use brackets. I always use parentheses. I don't think you can have an increasing and decreasing at an endpoint or at a maximum. And decreasing, that's obviously when it's going down. So I'd have open circle, and that's about it. So decreasing will be from 0 to 2, again using the x values. Bless you. And then constant. For today, we'll just say constants or flat lines. That'd be the easiest way around that, because we don't know a lot of calculus yet. So -2 to -1, it's constant, it's a flat line. Union with 4 to 5. See, that was fun. That's a fact. That's not my opinion, that's just a fact. It doesn't get better than that. Well, it does today, actually. Ready? All right, let's move on. We're getting closer to the word problems. I can hardly wait. We don't need to do this one, do we? X squared minus 1, everybody knows it's a parabola. You know, starts here and goes up. We can do domain, increasing, decreasing. We're in good shape with that. I want to hurry and get to the word problems. There's like one word problem that's really awesome. This is not a word problem, but this question you'll be asked to do at least 150 times before you leave high school, if you take the next math class. I kid you not, at least 150. This is known as the difference quotient. Now, a little known fact about the difference quotient is, how do you find, first of all, does this look familiar to anybody, the difference quotient? This part right here. Oh, this part goes along with it. It was. What's it mean? Oh, you got to know what it means. That's the fun part. Let's see. Let's go to somebody over there by the pink monkey. Somebody wearing pink by the pink monkey. There you go. That's you. Have you ever seen this before? Good. What did you used to call back in 8th grade? What? No idea? This is using function notation, isn't it? Function notation replaces what in the normal notation? F of x usually goes with y. Right, f of x goes with y. So if I take and rewrite this, watch this very carefully. If you have f of x plus h minus f of x all over x plus h minus x. Do you see how they get the single h down there? They actually subtracted the x's and they didn't tell you. Oh, another thing they didn't tell you. If you take your starting point with x and add a little bit to it called h, normally you call that the second x value. So this comes from the fact that somebody said, hey, if I take my original x and add a little bit to it, I'll call that x2. Same with this one, f of x1 minus f of x2. There we go. But still, you had f of x2 came from what? F of x stands for what? The what? The y values. So this came from the fact that you had y2 minus y1 over x2 minus x1, which is what? The slope of what? A line that connects 2 points, right? Nice. That comes from the slope of a line that connects 2 points, delta y over delta x. Now you're going to ask yourself, what the heck's have to do with this question? Well, easy. When you run a race or drive a car long distance, and you get there, say, in 6 hours, you have an average rate at which you travel, don't you? You take the total miles divided by 6 hours, and that's what your average rate was, wasn't it? Well, if you have a curved line like, 1 over x squared, it's a curved line, things like that. If you take 2 points and connect them, the difference quotient, which is this thing right here, is considered to be the average change between 2 points. You're like, well, that's not a big deal. It's not. But look at how scary that notation is. It's awesome. This is actually known as the average rate of change, i.e. the slope of the blank line. Mr. Father Geometry said, if you have a curved line and you draw another straight line through it intersecting 2 points, what's the straight line called? It has a special name. It has a very similar, what's this line called if it has 1 point in common? Tangent. This is calculus. In calculus, we work with tangents. You're not there yet. You're working with 2 points. What's that line called? It is the secant line. The secant line is considered to be the average rate of change on a curved map. Nice. See? Now you have all the background of your information. Does it help you solve the question? No, but it helps you to know what you're reading about. You're finding the average rate of change between 2 points on the graph 1 over x squared. Now let's get down to the algebra. Yeah.
Up there in the blue, the first step.
Yeah.
What is the h or the 2x's?
Oh, that's because when you have this single h down here, most people think it's a single h. They don't know that you actually subtracted the same x value to get that as your result. This is the result of years and years of mathematical thought that started right over here with rise over run. And you've progressed up to this point to here now, which gives you the slope of the secant line. In the next class, you don't worry about average rates of change. You worry about stepping on the gas of a car. How fast are you going when you hit the gas? That's what we worry about in calculus. All right. Oh, back to the algebra on how to solve this. Because the calculus kids have a quiz tomorrow, and this question is actually on it. 1 over x squared. So here's a silly question. If f of x is 1 over x squared, I'm sorry, does anybody want to do this instead of me? I'll sit down and take a break. Go ahead. All right. What is f of x plus h? How do you write that? Well, you write f of x plus h. What does it mean is the question. What does it equal? 1 over x plus h squared. Right. All over h. So I'm getting ready to leave the text. So I have f of x plus h minus f of x all over h. Dun, 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 dun. That's pre-calculus. I've lived up to my end of the deal. I have told you what that means. I have explained how to get here. Now your algebra teachers take over and show you how to solve that. How would you solve that? Based on your algebra training. Who's like the best? If we had like an algebra battle, who would we send out there to fight that battle? Excellent. You got to learn to point quick. People pointing at you or going with you. Yeah. Well, because how do you solve this? You got more points. How do you solve this? Well, you can't. Sledging gets a little messy on this one because see, you got 1, 2, you got like 3. That's only for a denominator with a denominator within a fraction. This doesn't really fall into that category. How do you subtract fractions? Yeah, common denominator, x squared and x squared. And there's an old saying in calculus and in pre-calculus is you don't multiply out the denominator unless you have to. And I've never multiplied out the denominator in all my years. And this one would be x plus h squared over x plus h squared. You want to make a calculus kid's day? Ask them to do this problem and see if they can. They'll hem and haw around, but I don't know if they can. I'll find out tomorrow in the quiz. Well, now I have a common denominator, right? And the sticking part is always this h. That long bar means what? To divide. Watch how I'm going to rewrite this. I'm going to rewrite this as x squared plus, let's see, here we go. X plus h squared minus x plus h squared divided by h. Okay? That's how I'm going to write it. I choose to write it that way. Going from left to right, Oh, on these problems, they always follow the same pattern. You hear me say this a lot. You have to expand it. You have to expand it. Then you have to subtract. Then you have to factor. And then you have to simplify. Yeah, nobody's ever been able to come up with anything. But you can try. Oh, to expand it, you have x squared minus x squared minus 2xh minus h squared. That's where a lot of people falter, is when they expand a binomial. And you still have this all over x squared times x plus h squared. And what do you do when you divide by h? That's what I would do. Multiply by 1 over h. You are almost home free. You've expanded. Now I'm going to subtract. Where do you subtract? Yeah. Subtract. Factor. What are you going to factor? Oh, contraire, mon frere. The h's. Oh, you want to take out negative h? That's fine. I would take out just an h, probably. 2x minus h all over x squared, x plus h squared times h. And now the last thing is you simplify. That means something different in calculus in this class. On this class, simplifying would just mean crossing that off. That's always your last step in this class, is you get rid of that lone h in the denominator. That's caused more grief, that lone h, than you can imagine. Getting rid of that lone h in the denominator. And that's your answer. That is an answer. It is awesome. A lot of work. I didn't ask you to take a spade and dig a ditch from here to Rantoul, 8 feet deep, 5 feet wide. That's work. That is just a little lesson in logic. Yeah. The difference between this class and the next class that comes in after you is I keep going. I know. How? I put a limit operator in front of it and have some more fun with it. What I just said. That's what it means. Limits will be around here in May 18th. I think the first one shows up at the door. First limit? Yeah. If I remember correctly. If a linear function satisfies a... Oh, what's this mean? That was so much fun. I enjoyed that a lot. Anybody else enjoy it as much as I did? Yeah, that was a difference quotient, by the way. You have to know that that's the difference quotient, f of x plus h minus f of x all over h. Can you remember that? Good. All right, so f of negative 2 equals 7, f of 4 equals negative 2. How do you find the equation of a line? I think they are. This represents what? The x, and the 7 represents the y. So this represents the x, and this represents the y. So how do you find the equation of a line through 2 points? I said you're going to be asked to find several equations of lines. You got to find the slope. Then what? Right. If I have a point, let's see, I'll go this way. 7 minus negative 2 all over negative 2 minus 4. That gives me the slope, right? y2 minus y1 over x2 minus x1. I'm not going to use a difference quotient because I don't have a function. I have points. So that gives me 9 over negative 6, right? Which is negative 3/2. There's my slope. I do them all the same way. Given slope, I pick a point, and I solve for b. I know there's other ways of doing it, but I don't do it that way. Well, actually, there's a third way I do it, but I'm not going to show you for a while. Easier, it is so slick. Oh, it's just like sailing on air. You can never make a mistake. It's foolproof. It is absolutely foolproof. Why don't you show us now? Because you can't use it on your assessment to see if you can stay in this class for Parkland credit. You have to be able to grind it out. After that, I'll show you. I'll show you all the tricks. Once you get in this class, you'll be amazed at how much you can do. Where was I? Oh, find B. Y is 7. M is negative 3/2. X is negative 2 plus B. Well, that's convenient. 7 equals 3 plus B. B equals 4. So Y equals negative 3/2 X plus 4. Nicely done. Questions? How much time do I have left? All right, you figure it out. I'll keep going. Perfect. Ah, what is this? The alternative definition of a function. This must be a big deal if I took this much time to type it out. A function with domain D is a set W of ordered pairs such that for each x and w, pair x and y and w have the first position. Yeah, I'm not big on this. Anytime it says alternative, I'm not big on it.
All right, next class.
Nah, I don't think you have to. I think you can omit these.
All right.
I'm not big on alternative definitions. They didn't have alternative definitions when I was a student. There's just one definition, and off you went. You didn't have the option of learning more than one. If you want to grind it out, you can. If you think it might be kind of cool.
Yeah.
Determine whether it's... Wait a minute. Determine whether a set W of ordered pairs is a function since... Determine whether a set is a function. Y squared minus x squared equals 1. That's not a function.
No.
That's a hyperbola, isn't it?
Yeah.
Yeah. There's a hyperbola.
Well, see, I wouldn't use the alternative definition. I'd say y equals 1 plus x squared. Y equals plus or minus the square root of 1 plus x squared. You can still answer the question. I don't think that's going to be one, though, is it? Y equals. Is it a hyperbola? I never got credit for that class, I don't think. Enter. Negative. Square root 1 plus x squared. I wouldn't use no alternative definition. I'd use a graph. Is that a hyperbola? Or not? Does that go the other way for hyperbola? No, that's one, isn't it? I never taught hyperbolas, though. Yeah, I'd say that's not a function. You don't need to use the alternative definition. You can figure it out. It doesn't pass the vertical line test. Therefore, it's not a function. Nope. Not a function. Alex, what's wrong? Oh, nice. I like that, too. All right. Oh, a box. The infamous box problem. This box will show up from time to time. And the sooner you learn how to handle it, the better off you'll be. That's just the basic facts. Constructing a box from a rectangular piece of cardboard having dimensions of 20 by 30. I will take my painstakingly time to explain how this works. Because the next time it comes up, I'll probably be a little bit more tired and grumpy, and then I won't spend as much time. And then when it comes up to 4th, 5th, and 6th times, I won't spend any time at all. So, how the box problem works, and the reason I bring this up is it shows up all the time. You take a rectangular piece of cardboard, 20 by 30. And the pictures are here, but I won't give you a picture on a test or on a quiz, okay? I don't like messing with pictures. I just like to type. Actually, I like to scan and not mess with pictures, but 20 by 30. And then you cut out, you nibble out this area of the box. And the flaps are folded up. The resulting flaps are folded up, okay? So you have, the basic shape. You can use sheet metal for gutters. You can use cardboard for boxes. You can use all kinds of things. And the flaps get folded up, okay? The biggest problem is people say, I don't understand how the box is made. Well, that's how the box is made. You cut this out and fold the flaps up, and there you go. By the way, this is the best picture I've ever seen for this problem. Anyway, express the volume of the box as a function of x. All right? How do you find the volume of a rectangular prism? Yeah, length times width times height. Those equations you obviously have to know because I won't provide them for you. And the easy one is always the length. They always take the 30 and they always subtract the 2x's. Sorry, I'll do it this way. 30 minus 2x. That's always the easiest one, the length. The width isn't so bad either. 20. And they subtract what? The 2x's again. So this is 20 minus 2x. That sticking point, and they gave it to you on this one, which I'm a little ticked about. I didn't have any control, is the height is x. It's really easy because they gave it to you. Now, the box problem can change. If you cut out 1 square foot, if you cut out 2 square feet, things like that, changes your height. Now, in this class, or in this section, we will stop right here with the problem. And the answer is just all three of them multiplied together. V equals 30 minus 2x times 20 minus 2x times x. Okay? And that's length times width times height. Now, it says expressed as a function. So technically, you need an x right there after that. That is function notation. Do I take off for that? Only if I really don't like you. If I'm looking for a way to get points from you, I will, but otherwise I'll just leave it be. All right? So that's a volume function of x. And you can multiply it out if you like, but usually I leave it like that. Okay? Is there a part B to this? There can't be a part B yet. We're too soon in the book. All right, expressed as a function of x. Nice. Nicely done. Questions on that? It went easy with the picture, don't you think? All right. You know what this is? No, it's an open box. The open box problem comes up all the time. Oh, well, this uses the word aquarium, but still, it's an open box. Guess which problem is better than the open box? The closed box, right. The closed box is better. Good. All right, so the aquarium is 1.5 height, and volume equals 6 cubic feet. H equals 1.5. B equals 6. Let x denote the length of the base and y the width. Oh, look at that. They've already got it on there for you. Okay. Express y as a function of x. Do you know what that means? Express y as a function of x? What? Oh, express y as a function of x means you have one single y, and x is your independent variable. You can have as many x's as you like, but you only get one y. It has to be equal to it in case you want to graph this out later, which we will. So that's how the words work. Y as a function of x. Some people think of it as y of x equals in function notation. Okay? That's what the words mean. You're going to do a lot of function notation. So I have to figure it out. Based on all this, I know if I take x times y times 1.5, that's the length, times the width, times the height, what's it going to equal? 6. So how do you get the y by itself? Yeah, divide by the 1.5 and the x. So y equals 6 divided by 1.5 x. What is 6 divided by 1.5? 4? Is it really? Y equals 4 over x. Just as a side note, what type of function is 4 over x? Close. No? No, not a sideways parabola. Hyperbola, no. It's the reciprocal function. It's got graphs like this. It helps to know what you're looking at before you graph it out in case you make a mistake typing it in. Did you get that, Jessica? Reciprocal function? Nice. We're moving on. Express the total number of square feet of glass needed as a function of x. Ooh. Well, how do you figure out how much glass you need? All the sides except for the top. So I have a base. How big is the base? X times y. So I have x times y. Oh, well, I don't need a top, do I? What about the front? What's the front going to be? Yeah, the front is going to be 1.5x. I need two of those. Yeah, good. One for the front, one for the back. So I need two of those. 2 times, which is 3x. So I got the front, I got the back, I got the bottom. And what do I need? Oh, yeah, you said 3y. Because there are two of them, 1.5y for the sides, left and right side. Oh, now you add them all up, right? So xy plus 3x for the front and the back, and 3y for the left side and the right side, and that equals the surface area. But it says to express it how? As what? As a function of x. So my answer has to say s of x equals, and I get only x's as the variable on the right side. What? Go ahead. How do you get rid of the y's? No, from part A. They're hinged together with x. How? For every y, you get what? 4 over x. That's a substitution in part A. In part A, it tells you how to substitute it in. It says y equals 4 over x because this aquarium has to have 6. 6 what? 6 cubic feet. Yeah, you plug in 4 over x for all the y's. And that gives you the surface area as a function of x. Do you know why people want to write equations as a function of one variable? Any idea? Any reason at all? No, it has nothing to do with graphing. Okay, great. It has nothing to do with graphing. What do you think it has to do with? Oh, come on now. All right. I'm going to tidy this up a little bit. It has to do with linear programming. If you want to come up with dimensions for something, if you type in one number to a program and gives you all the information, that's very efficient, very fast. You just take a problem now and you can generate all kinds of surface area questions by putting in different numbers for x. You can run simulated models. Have you ever been on a program where you drag something and the shape changed? You know, the geometric shape changed? Have you ever done that in the lab? Okay, maybe not. All right, but it works. Yes? Oh, I got a common denominator. I'll multiply everything by x over x. Because that's probably how you'd see it in your textbook anyway. All right, so finish this up for tomorrow. And then we'll probably answer questions or some more word problems. Try to get our 5 for 10 in tomorrow, okay? That means on Thursday we'll start 2 point... What section is this? Yeah. This is 2.4, so we'll start 2.5. All right, so what page is this? 150. So we're finishing up going to 60 what? 67. And we're starting where? Around 30 some? 35. All right. So I'll answer questions tomorrow. Great job.